So you were asked to somehow show or explain how these are algebraically equivalent, which means that these are essentially two different formulas that both accurately and will always calculate the midpoint. So basically, these two formulas are essentially the same. So when we try to test something like that out using algebra, I mean, we could put some numbers in and try it out, but again, at that point, we're only trying it for certain numbers, whereas a more of an algebraic proof, which is what we're starting to learn about just doing proofs in general, it's a little bit more problematic because I have to just use variables. But by using variables and making sure that I'm keeping everything straight, I'm showing it's going to work for any possibilities for A, B, C, and D. So the question we're looking to try to answer here is the referee's formula, which is 1/2 C minus A plus A, comma 1/2 D minus B plus B, is that the same thing as me saying A plus C over 2, comma B plus D over 2? And I have the question mark above the equal sign there because I don't know if that's true yet. But if I could get the two sides of this equation to be the exact same thing, either by altering one and leaving the other one alone, or altering both of them until I get, some sort of formula that's identical on both sides, then I'll have done my job correctly. So, on the left-hand side, what I'm going to actually do, and I'm not going to write out the reasons because I'm going to be doing sometimes different things on both sides of the equation, but I will explain to you what allows me to do them, because that's always a premise you should always go by. If you don't have a reason or there is no rule that allows you to do it, you probably shouldn't be doing it. But on the left-hand side, I could use a distributed property for those 1/2s. So I can rewrite this as 1/2 C minus 1/2 A plus A, because that was the plus A was not inside the parenthesis. And a very likewise 1/2 D minus 1/2 B plus B. And much like multiplication, division is also distributive. So having A plus C all over one fraction bar divided by 2 is just like having me have A over 2 plus C over 2, comma, B over 2 plus D over 2. So now what I'm going to do is on the left-hand side, before the comma and after the comma, I do have some like terms I could combine. Here I have negative 1/2 A plus 1A. Here I have negative 1/2 B plus 1/2 or 1B. So if I carry those through, I'm going to end up with 1/2 C. Negative 1/2 A plus 1A is going to give me a positive 1/2 A. 1/2 D. Negative 1/2 B plus 1B is going to give me a plus 1/2 B. On this side, dividing by 2 is the same thing as multiplying by a half. So and as you can see, in the first sets of coordinates, before the comma, I have 1/2 C plus 1/2 A on the left. I have 1/2 A plus 1/2 C on the right. By the symmetric property, just to save me some writing, these are equal by the symmetric property. If I simply reverse not the symmetric property, commutative property, I'm not taking it across an equal sign. So commutative. Which basically addition can be reversed. I could do it in any order I want. Same thing with these two. So essentially what I've shown is that on the left I have 1/2 A plus 1/2 C, 1/2 B plus 1/2 D. And that's exactly what I have on the right. And these are equal, so I've proven that they are algebraically equivalent. If you have any further questions, please ask your teacher. Until next time.